Good morning, good afternoon, good evening to people around the world. This is your host of the DB2Night show, Martin Hubel. Doing this now for, I guess, 11 years minimum. I'm really pleased to have Jim Bean back with me again today to do part 2 of his database performance presentation. Jim, how are you doing today?
I'm doing very well, Martin. Yourself?
I'm just hanging in there. It's just a great day. There's a little bit of concern in the world, but we're going to work through it and talk about DB2 instead. And I think that's the only thing we really can do. Having said that, let's get me out of the way, do our polling questions and other such important things, and then we'll turn things over to you. As always, we have our Get Involved page. We have the replays now available on YouTube. I put that up top because that's probably the most important thing people should see. We also have the DB2Night show hashtags and things of that nature on Twitter and emails and that sort of thing that we send out to remind people about the show. Then we have our LinkedIn group where we take suggestions about the show. So let's moving on. Here's our trademarks and things like that. We make replays available. If you say anything out loud, it will be recorded, and we respect trademarks, and the things are made available afterwards, as we've just said. I could read that. I used to do that about 10 years ago, but in the last 5 years, I've gotten a little feeling like I don't need to do that anymore. Hope you agree. And with that, our upcoming shows. I'm expecting to have Dale McGinnis next month on AIX to Linux migration. This seems to be a popular thing. I've worked with an awful lot of customers that have large AIX machines. Some of those people have decided to save some licensing money and that sort of thing on commodity hardware with Linux. And so Dale's going to talk about that. IBM is also heavily pushing containerization, and we've had presentations of that on the show as well. And also moving to the cloud. I've got customers still looking to move to the cloud. On the Z side, we have Michael Cotignola of BMC Software, kind of doing all of the hints and tips he could remember of things that when he goes to customer sites, what he needs to do. He's a longtime DB2 consultant for BMC. And Cheryl Larson is back with us again. She's a very popular, well-known speaker. I think Cheryl, myself, and another frequent speaker on the DB2Night show, Dave Belkey, are the 3 people that are still presenting today that presented at the first IDUG held in Chicago in 1989. So that's our claim to fame. Although Cheryl looks a lot younger than I do. At the time, I think I looked fairly young. Who knew? Still doing it. And also on the Z side, we're expecting to have 2 IBM speakers from the lab or from their SWAT teams and that sort of thing. They asked me for those slots, and we're looking forward to having speakers from IBM in May and June. Also, the speakers in May and June will also be on DB2 LUW lab speakers as well. So it'll be a slam bang finish up to the year. As always, DBI Software is our primary and founding sponsor of the DB2Night show, and we thank them for their support. And as always, we like to give them a little bit of a plug in the show, and you can watch their demo on their website. The link is there. There's a demo. You follow it. If you watch it all, you get a Starbucks gift card. Whoops. I accidentally clicked on that link, so on my other screen, I've got a chance to get that Amazon gift card. That's the first time I've done that in a while. And our winner last month turns out to be a friend, Jimmy Gant from Colonial Life. Did some work with them a year or so ago. It's kind of interesting. And again, thanks to our sponsors, yours truly, Martin Hubel Consulting and DBI. And I believe now, so here's my little joke for today. I found this, I was going through and saying, should I It's kind of a strange time in the world, but at the same time, we need to keep things lighthearted and keep learning and working at our jobs. So found this flowchart properly designed with the heading right off to the side where it should be. Not really, but things you fix with WD-40 and duct tape. And, does it move? No. If it shouldn't, then you use if it shouldn't move, you use duct tape. If it's supposed to move and it doesn't, use WD-40, and there we go. 2 plugs for WD-40 and duct tape, but who doesn't have those products around your house? So we're now into the polls. Let me get this organized here. Standard questions. The first one is, which DB2 versions are you currently running? I'm pleased to report that 10.5 and 11.1 are now combined all to the earlier parts of our screen. I'm sure there's people still running 11.1 or earlier based on vendor certifications, or if you're a real busy and older LUW customer, of course, you have things that are harder to move and migrate. So the more we have that going on, there we close that and share the results. We got a lot of people running new, and we got a lot of people running old. That's hardly a surprise. All right, we'll hide that and move on. And which operating systems? And to be honest, we used to see more Linux than anything else. These days, now that IBM owns Red Hat and people are moving towards Red Hat, we're seeing Red Hat being the hotter one these days. SUSE, of course, and other Linux like Ubuntu and other such things are out there. And there's even people running DB2 on Windows in kind of a large way. So let me close that off and share the result there. Red Hat has taken over, according to our audience today, although AIX is still a big and important thing. And if you're a bigger DB2 LUW user, chances are you are using AIX. And which monitoring tools do you use? And again, this is another one. You can put all that you want. We like to, in here, we have a little bit of a plug-in here for the DBI tools, and we do have a number of people that are part of the our DBI customers, and we're always happy to see you. And there we go. I'm surprised the design advisor is as low as it is. But I can tell you, I love it on DB2 LUW, and it seems to do a pretty good job on System Z. I'm using it on an AS400 customer right now. Boy, am I not happy. It doesn't work as well as I've been used to seeing it on LUW. It's putting that idea out there. So let's share that and show that everybody uses Explain, everybody uses DB2 Top, and other vendor tools, and the design advisors lag in there a little bit, which is interesting to note. And our last question here should be, do you consider your performance? And this is, you only get to choose one this time. One thing I've learned about performance is there's always somewhere to fix. And fixing performance is still a good way to make customers happy and to also save some money. So I think performance tuning for databases will always be a big thing, and understanding I/O and that sort of thing. So with this, I'll close that off. And this answer really doesn't surprise me with our fine, good-looking, intelligent audience. Reason being is that people can get to satisfactory, and there always are areas to fix. And anybody that's not watching the show probably hasn't been watching other presentations as well, and they probably aren't here. So we'll hide that. And that's the last question we have. So I'm going to move over here. And Jim, you're up. So let me make you the panelist. or the presenter rather. You are a panelist. So now you should have a button on your screen to click.
And I don't.
Really? Ooh. Okay. I'm actually seeing that you are the. Interesting. Interesting.
I think you grabbed the wrong Jim Bean. There's a couple of Jim Beans out there.
Well, actually, the one that has this, the only one that had a unmuted button was you. So I thought I grabbed the right one. Let me try again.
Yeah. At least on my display, it's the one directly below.
Oh, all right. But it says you're talking on a phone, if that's the case.
That one also is not me.
All right. Hey, we're having fun here. This is for the people, for our audience. Jim did his friends a big favor and sent them his link to the show.
Which you should never do.
Well, it just means that they all I've got 4 Jim Beans, and I'm trying to choose the right one. Are we there yet? No, that one's muted. The only one that makes sense is the one I first clicked on, because it's the only one with the microphone unmuted.
You let's see. I think you may have gotten me.
Oh, yeah.
Nope, that's not me either.
There are. I'm sorry to say. You know how many?
You got to scroll. There's a few, quite a few.
That's great. You have that many friends. That's fantastic.
There we go.
What a yeah. You know, there's 12. There's 12 people in staff, and there should be 2. So there's 10. No, now there's 13. So you've passed out this link to a lot of people, and they love you. They came to see you. That's great news.
I guess so. That's great support.
Yes, that's right. That's perfect. And this will go down in the annals of DB2Night show hosting history. That's fantastic. Take it away. Oh, you were there. I saw your screen and it went away. There you go.
Yeah, and I just switched.
Good.
So you're seeing the full screen. Okay, so this is part 2. Thank you, Martin. Sorry about the confusion at the start here, folks.
No worries. I'll break in with questions as need be.
Sounds good. And just so folks know, we did part 1 of this presentation back in mid-December. I believe it was Friday, the 10th of December. You can go back and view that, as Martin said, because they're all out there available on YouTube. Now, this is a part 2 of basically the same presentation, but different topics within the major subtopic of optimal database performance. You can certainly attend this topic before part 1. You're not going to miss out on anything, but I would suggest you go back and take a look at part 1 also, just because there's some good information there. In fact, I'll just mention some things real quick as we're going through here. We talked a little bit about hardware, software, and concurrency. I'm sorry, not concurrency, currency, meaning you're up to date on your versions. Because in there, I even got into some costs or some problems that you could encounter if you're not current. Also talked about using hardware, optimally, and especially in a partitioned environment. Talked about some DB config stuff at a very high level, and in particular, we did cover quite a bit on the package cache and using parameter markers, and then the impact of doing it properly, so that, in one example I showed, it was tens of millions of compiles being eliminated per day, and at a millisecond or a few milliseconds, that really adds up quickly when you do the math. And in there too was an example of not using parameter markers, because sometimes you don't want to use a parameter marker. We covered some maintenance topics, things like reorgs, looking at overflow accesses to see, when you're really being impacted by those additional physical IOs that are resulting. Talked about some run stats at appropriate times to resolve some issues. And then we also touched on data archiving and purging. Of course, we all do that, right? Well, we have some applications that didn't, and they are now, thankfully. And there's a couple different approaches to that. And today we're going to take on the second half of the presentation, which is starting with SQL. So we'll get into that. And this first topic is something you hear all the time. Don't use select asterisk. Well, sometimes people don't tell you why not to use select asterisk, and I'm here to tell you why not. We see it all the time, but we hear not to use it all the time. And the reason is because sometimes it can require you to do additional work in your programs, because now you're going to be potentially selecting extra columns if, for example, the table's altered. But more importantly, from a guy like myself who's heavily into performance, it can make a humongous difference, a huge difference, especially if you're doing physical sorting of that data, because now you're bringing back data that maybe you're not interested in, maybe your program doesn't need, your customers don't need to see. Then why bring it back? Why sort the entire thing if you only need a handful or a subset of columns? And this is where it's real important too, is if you're tuning SQL calls and you're looking at indexing, it can make a huge difference for index-only access considerations. Maybe you only needed 2 or 3 columns from the table, but if you're doing select asterisk, you pretty much ruled out any index-only access. Another thing, and I'll actually show an example of this, or might even be a few, on proper placement of parentheses. And I know this sounds very simple, but it's amazing some of the errors we've seen out there and some of the impacts that those have. And obviously, there are times when you need parentheses, of course, and sometimes you might want to use it for clarification, depending on how you're formatting your SQL. But just be careful and be very specific about what you're doing. And my personal feeling is to avoid unnecessary parentheses because it starts to get confusing, especially when no parentheses are needed and people start throwing them into their SQL. Incorrect parentheses placement, yep, that can lead to some issues that lead to performance issues, but more importantly, it can actually invalidate your query results. And we'll have an example of that. Watch out for any unnecessary sorting, order by, group by distincts. That can lead to issues, of course, and affect performance. And simplify your SQL as much as possible. And we'll look at an example of this that had a ton of functions, and it impacted index usage, and it just didn't make sense. And well, the example we'll go through that. But here's the first one. This one talks to parentheses. And you can see that there is a situation in there, if you look about a third of the way in, where they're looking at 2 different producer codes, or at least that's what they thought. But the way it's coded, it's very different. And again, it gets back to the way the parentheses are. And I would also offer up that there are a lot of unnecessary pairs of parentheses in this SQL statement. So what happened here, DBA reached out to me that they were having some poor performing searches out there. This is from a FileNet implementation, one of quite a few that we have. And looking at this immediately, because once you start to look at FileNet searches, you start to get used to the way they get formatted and created out there. So what I've done here on this slide is I've kind of reformatted the SQL a little bit just to make it clear. I left all the parentheses in. The red part there is the first producer code they're looking for, and then there's that OR clause, but you notice the left parentheses right before it. Well, the way DB2 is going to handle it is putting all of those and criteria in there. And again, if you're familiar with the way FileNet generates its queries, you'd probably say this doesn't look quite right, and you'd be correct. Plus, if you think about it, they're probably looking for 2 producer codes with those other criteria, and not 1 producer code or a second producer code with those other criteria. So obviously there's something awry here, but reformatting it and adding the color always kind of, clears it up. So this is what they really intended. So what I've done here is I've kind of cleaned it up a little bit. I moved the OR up to the same line, keeping the colors, the red and the green, so you see that, and I got rid of all those other parentheses. So when they ran this, of course, it corrected the performance issue, and the more important point that I made earlier is that it also fixed the results of the query. I don't even know that they realized that they were getting invalid results, because sometimes I'm not sure if they really truly understand the results coming back. And then, of course, another thing you could do here to make it a little cleaner, a little easier to read, something that I prefer, is that you go to an in clause. That eliminates the whole OR situation. Yes, you still have parentheses around your in clause values, but it makes it a lot easier to read. In fact, that's this version here. So this is how I would prefer to see the particular SQL call, because it's very clean, very easy to read. And after I looked at this, I know I focused on the producer code, but certainly that statement date could be a between clause. They just chose not to use that, or it didn't get generated that way. Now here's a different example that I took from the IDUG virtual conference a year and a half ago when it was virtual because of COVID. And here's an example. If you look at the top half of that chart, you see the SQL call, and it's just loaded with functions. They're trimming stuff, they're doing uppers, they're just doing a whole bunch of stuff. This is very, very data dependent. You need to know your data. So the first thing I did when I took a look at this, and you'll see why on the next slide or so, is I actually looked at the data to find out, well, what's actually going on. And I found out that, well, they didn't need the upper because everything was in upper already. They also didn't need to trim anything. So the SQL could be rewritten as you see below with no function calls whatsoever. Great, so that's going to happen. And oh, by the way, this was obviously a performance problem, or else we wouldn't be looking at it. It wasn't a big performance problem, but it was big enough. So again, here I say that I took a look at the data to make sure, and then explained, said, hey, you're going to get some pretty big improvements here. And point 2 shows it, because now DB2 is going to use the index on SSO ID. Let's go back one slide here. Earlier with the trim SSO ID, DB2 is not going to use the index appropriately or optimally. After the changes, it did. So that's why we saw the huge improvement. So it's not just due to eliminating the functions, because it also gave DB2 the ability to then use the index on SSO ID optimally. And it has very good cardinality, so we get very good performance from this. Technically, we could have made the index a little bit more optimal by adding these other 2 columns, but we never had to. We never created it because the call ran just fine with the index on SSO ID, again, which had very good cardinality. So again, we just made these SQL changes, didn't have to make any index changes or add an index. And I forget where these were running originally. I'm not sure. I may have included, yeah, I did include the slides, but we'll see that the call dropped down to, most days we weren't picking it up, and when we did, it was like 0.76 milliseconds. So a big improvement. Here are the explains, and I'll do a little, hopefully you guys can see this a little better when I zoom in. You can see originally a very high cost because it was actually using the index, and it's using a terrible index in this particular case for this call, very high costs. And then it had to bring that data together, and then using list prefetch, go out and start accessing the data. Very, very inefficient. With the proper not index, with the SQL changes that we made, it was able to use the proper index on SSO ID. Again, the first column, and it has very good cardinality at 630K, and the cost dropped down to almost nothing. Much, much more efficient. And you can see the comparison at the very bottom. These are some charts out of a tool that we use here called Database Performance Analyzer for this particular SQL call. And you can see where, the number of executions are high, sorts are high, rows read extremely high. Just to kind of zoom in again to give you some numbers, we're talking 125 million, or over 125 million on that particular day. So these are daily counts. Afterward, the calls ran much faster, as I mentioned. A lot of days we weren't even catching them or picking them up, and you can see the rows read are significantly decreased to what we had before, because we're only at a max of around 2 million per day. So that's it on SQL. There are more hints and techniques and guidelines and things to look at various presentations that I've done over time that you can see either at IDUG or in the from CCDUG, the Central Canadian DB2 user group as well. And we'll see some links later. Indexing, though, is the next topic that I wanted to kind of dive into. And again, there's much more on this elsewhere. Other folks have done some terrific presentations on this as well. You can't possibly cover everything, but there's some things that I wanted to review, things like unused indexes, single column, and no multi-column indexes. We see that a lot in a lot of products. Multi-index access versus multi-column, sorting, RI, index-only access that I mentioned earlier, and using include columns, one fetch access, expression-based indexes, and a relatively new feature. Actually, those 2 at the bottom are both relatively new. Now, what do I mean by that? I believe they both came out with 10.5. Relatively new means I haven't seen them used a whole lot. In fact, that last one, exclude null keys, we implemented for a FileNet application recently at Cigna, and that's the first time I think that I've ever recommended putting that in. So for us, it's still relatively new, even though it was put into place under 10.5 a couple of years back. Now, indexing and indexes out there, a lot of applications, you get kind of like an index growth out there where indexes are created all over the place. And we've seen that in some environments. And we see a lot of this with products that have indexes on a single column. and there's just a lot out there. So in general, whenever I go out there and I start looking around at indexes, one of the things that I always like to do is I take a look at production to see if all the indexes that are out there are truly being used. And there's a query here that you can use to do this. It's pretty simple. It just goes against sys indexes. And well, why do you want to do this? Well, why have indexes that you don't need? So if you're going to go through the difficulty, the expense, the time of testing a new index, why not get rid of the ones that you don't need and test your entire application and make sure that you don't have indexes that you don't need. A lot of times we find never used indexes or not recently used, redundant indexes, etc. But keep in mind, it's somewhere in here, I'm just not sure where I put it. You know, you may have not recently used indexes. Are they only used at a monthly period of time? Well, are they candidates to be dropped and recreated? Maybe they're only used quarterly or annually. Definitely look to see, hey, do I need to maintain those indexes year round, or should I just rebuild them when I need them and then drop them afterwards? So there's things you can look at. We all know there's a lot of, maybe not a lot, but there's a noticeable overhead of maintaining indexes, especially if you get far too many. The other thing you can do when you're looking for redundant indexes is run that query above, but order by column names as the third order by parameter. The reason there, column names gives you the actual column names that are on the index. And then that way, if they're all grouped together, you'll see if you've got the potential for some redundant indexes. This next dot point version, there used to be is the key, some issues with getting the proper last use value out to the sys indexes table. So it wasn't reliable. You really couldn't use it. That was a long time ago. That's been corrected, and I've never heard of a problem recently. So we do use this method on a regular basis, or at least I do. But we still go back and test. We still run all of our testing to make sure that any indexes we're eliminating, don't have any impact. Now, single column indexes versus not having any multi-column indexes. The reason I put this in there is you'd be surprised how much I see this. And it happens a lot, believe it or not, with IBM products. And I'm not going to get into names, but there are a multitude of products out there that, for example, they may not index every single column, but every index that they have is on a single column. And, they may have 15, 20, even much higher number of indexes, and they're all single column indexes. And in some cases, the optimizer is choosing to use a single index, and sometimes it's using multi-index. And we'll get into that a little bit coming up. But, DB2 can only work with what it has at its disposal. And in some cases, that single column index is perfectly fine. That works out really well. But in other cases, it just doesn't make any sense. And again, we see this a lot more often than you'd think. So here's a real simple example, though. We were getting some FA utilization alerts from our storage team, and actually they were prepared to add resources because they thought it was a problem on their end. They thought they needed this additional hardware to resolve this issue. We started poking around and working, with our DBAs. And what we found was real simple. We just needed an index on this one column on this table. I forget how big this table was. This data warehouse, there are probably hundreds of millions of rows, maybe a couple billion. And we were doing table scans all over the place because there were no indexes on this table at all. And there's a delete here. So imagine the locking. Imagine the time for the locking as it's scanning through these rows. Now, this was a partition environment with 8 parts, so you got multi-stuff going on all the time as it's doing the I/O and using async I/O, driving multiple I/O paths. But still, it just does not make sense. Put the index out there if you need the index. This made a huge, huge difference. And you can see the drops that we saw in the physical reads that were going on. This is on one particular day, and it's just incredible. What we ended up saving was 3.25 hours per day, 198 billion logical reads per day. Again, you can see all this in there. It's just incredible, the amount of time. And what was interesting is afterwards, most of the physical reads were from daily backups, and that makes perfect sense because we fixed that. And of course, we did not have to do the hardware upgrade or add hardware to the system. This is just one of the, which one was this? This was the select column. You can see where the time basically dropped to near nothing. In fact, most days afterward, after implementing the index, we weren't even catching them. And when we did, the times were just so incredibly fast. The rows red dropped to next to nothing. The other thing that was interesting too, you can see it toward the right, the buffer pool hit ratio improved greatly. Well, of course, because we're no longer scanning this humongous table repeatedly over and over and over. So, talk about some multi-column index things. Of course, SQL just keeps getting more and more complicated every day. So of course our indexing has to, the optimizer has to expect that and be prepared for that and handle that. One of the things I like to tell my colleagues, and we discuss quite a bit, is, when talking about indexing is, what's optimal? What is the best index? And in general, you want to think about things like, well, I want the smallest index that's going to give me the best filtering. That way, of course, you're going to reduce your physical I/O. And when you're using multiple columns, you got to look at the length of each column, and that's the actual length. And also look at the screening and filtering that it provides. Of course, you don't want to include columns that provide no benefit. We'll actually see some of that in just a moment. Think columns that have cardinality of 1, but sometimes, believe it or not, and here's the exception. I don't think I included the slide, but sometimes you do have to include a column that has what I'd call no value because cardinality is 1. We found sometimes that we have to sway the optimizer to use a particular index. And I'm talking not using a hint because we try not to use hints, but sometimes you have to sway the optimizer. And we'll actually put on a column or two that even though it has cardinality 1, the optimizer seeing the equal clause and gives it more weight. Especially don't include those really long columns that provide little or no benefit. Same kind of thing, low cardinality, low filtering. And of course, you have to keep in mind what's indexable, the equal versus not equal versus likes, not likes, ands and ors, ins or not ins, etc. And you got to keep all that in mind too. Now, in general, when you see multi-index access, that almost always tells you that, hey, there's something wrong. DB2 can't find everything it wants on a single index, so he's going to have to use 2. Okay. Now, why? Well, that's not so good because now you're talking about keeping index pages in the buffer pool for potentially for 2 different indexes, and maybe you only need it in there for 1. You're talking about doing some more index scanning. You're talking about bringing them to go together and probably anding them together. There could be physical sorting involved. It brings in a lot more work, and we saw that on one of the prior slides there where I showed and explained. I think there's another one coming up. So just keep in mind, the more indexes that are involved, even if it's the same index, if you're using the same index in multi-scan mode, same thing, there's something going on there. But the more indexes involved, the greater the opportunity. And again, that second dot point I've kind of covered. So in cases like this, it's a good idea to take a look at the SQL, and not only that SQL, but any other SQL too, of course, and see if you can come up with a better multi-column index that has all of the necessary columns so that DB2 can use just 1. And again, there are exceptions to this. Sometimes you need the 2 indexes, and I think I have an example of that. And then, you can do some things with what I call overlapping columns, and we'll see that. So in an example coming up here, we actually had a couple of indexes out there, several. 2 of them were being used by a call on an account number and on a client ID. Well, there are SQL calls that come in that have both. And what we were seeing was the optimizer was applying both indexes in a multi-index access path. And you may say, well, that's okay. Yeah, it performed okay, but it wasn't great. But it did add additional workload to the system. And the reason it was important, because these other indexes that we've set up to cover the sorting requirements as well. Excuse me. What I mean by that is for our searches, we try to eliminate physical sorting as much as possible by including not only columns that are used in the where criteria, obviously, but also columns in the order by, and we do it in such a way so that we don't have to have any physical sorts. They get eliminated from the access path. That's all fine and dandy. Once we had 2 indexes involved, remember what we saw earlier, it uses both indexes, it ands the conditions together, it's doing all these intermediate sorts in there, and that totally blows out of the water our sorting that we were doing, or not that we were doing, the sorting that we were preventing with our index design. So again, that all gets into all of this. So anyhow, we'll see this, and hopefully that'll make that more clear. So again, I mentioned the physical sorts. These 2x and 4x indexes, again, specifically created for other search calls. We did not want to change them in a way that would affect the performance of those other search calls, so we don't want to mess those up, but there's a way to do it. So what we did was we added client ID to the existing 4x index, which is the account number. So now we have both of those columns on the same index, but we put it down at the very bottom. That way we didn't mess up any of the existing access paths, and that's what we'll see here. So now this is the original access path, and I'm going to zoom in a little bit so you can see again. And you notice DB2 is using the 4x and the 2x. Well, let's see, this is the 4x on the account number. And then down here, we're highlighting the 2x, which is on the Signet client ID. So again, DB2 is using those two indexes. And if you look at them, you can kind of see they have the same exact setup, the only difference being the first column. And you can see what DB2 is going through. This is the sorting I was talking about. So you got the two index scans, the index anding, and now there's a sort. Oh, now there has to be a sort out here to meet the other criteria, you know, the order by criteria. So now let's take a look at what we did here. Same SQL statement, much lower cost, much simpler access path. And why? Well, because Jim took this 4x index and we added the client ID at the end. So now we're handling the OR condition. And again, we could have done it with a hint. We just chose not to. We try not to do things with hints if we don't have to. So it's the same first four columns. We put the client ID on the back end. We did not use multi-index scan, so that didn't introduce any intermediate sorting, which also, by the way, has to bring back all of the qualifying rates. That's the other thing, you know, when we do this, we're just bringing back the data that we need. And then the other thing that we did too, because we preserved these first four columns, there's no physical there's no physical sort to meet the order by criteria, hence the very low cost. So now when DB2 executes this SQL call, it just goes in and applies these conditions, sorting on these other conditions, which isn't a physical sort because it's in the index, which the index entries are sorted. And then it also applies the client ID. So it was a huge reduction, as you can see. Oops, sorry. Huge reduction, as you can see. Speaking of sorting, this is another big feature of indexes that I like to employ all the time, is to get rid of physical sorting, especially when you have tables that are millions and millions of rows or billions of rows, which is not unheard of these days. I'm sure a lot of folks are dealing with large volumes, and you've got calls out there with order bys, group bys, or distincts, and that invokes a physical sort of the results. Now that may be okay in batch because that's what you're doing, but in an online environment, we've seen some of the queries, and I forget if I have some examples somewhere. They might be coming up. Yeah, I think they're coming up. But anyway, you may only be looking for the first 100 rows or 400 rows or 1,000 rows, or maybe you're only looking for 24 rows because you're providing, you know, one page of output to a user. And, you know, there's no need to sort through, retrieve all this data, sort it, and then provide only the first 20 rows to a user. So there are other techniques that you can apply, and that's what we're going to look at, especially when you're paging through multiple rows of data. And sometimes you might want to even use this for batch as well, especially because remember in batch, you're going to most likely commit some point, and you've got the cursor withhold option, but you may also want to have proper indexing to handle it for you too. So here's a SQL statement. Again, this one also is also from a FileNet implementation, and you see what I was talking about, the fetch first 1,000 rows, optimize 4,000. Those are kind of high, but that's what they're doing. You also see some other things here too, like you can call them worthless columns or whatever. The second and third criteria each have cardinality 1. They're always null, so they really don't add anything to the filtering. But believe it or not, we've actually put those into indexes sometime to influence the optimizer. Anyhow, getting back to what we're talking about, you'll notice that there is an object class ID where criteria is the first one up there. It's an in clause, but it's really an equals. You also see one on version status, the fourth one also an equals, and you see a lot of unnecessary parentheses. And then you also see the search type criteria on 2. So you do need a pair of parentheses there around the search type, but that's the only one. You could get rid of, I don't know, at least 4 other sets of parentheses. Anyhow, getting back to the point here. So an index on version status, because that's a very small column, object class ID helps, but those are our only true equal conditions. Next, it's followed by the document title and the object ID. Why? To eliminate our physical sort. You see the order by there on document title and object ID? Well, this query, even though we've got a couple of equal criteria, it still brings back quite a bit of data that qualifies. Now, we could either bring back all that data and then physically sort it and then start providing it to the user. Or we can kind of go through the index in the, I guess, order by sequence. So we're applying the equal clauses ahead of time because they're just equals, and then we go into our order by clauses and provide the data back in that particular sequence. And at the very end of the index is the search type column, which is our OR criteria. There's two different ones that apply. So what we're doing again is kind of like stepping through the index, resolving those in conditions on the first two columns, and then applying the order by columns, and then applying some screening criteria using the search type or final condition. Likewise, a query like this probably has other invocations that use a next page where they apply additional paging where criteria on those order by criteria. Works with that too. And it does the same thing because, again, it's applying the equal criteria on the first two columns and then using the index to resolve the physical sort so that there is no physical sort at all. And you'll see this in the explain. And at the end, as I mentioned there, it'll apply any other additional filtering criteria on search type. It can be very beneficial in processing large amounts of data, even in batch, as I mentioned earlier. And instead of having to retrieve and fetch all the qualifying data and then sort it, instead you just step through the index. And it works even better if the table data is clustered by this index. And it does make a big difference in OLTP because now you're talking about maybe getting 20, 30, 40 rows of data and not bringing back all the data just to sort it and then provide those 20, 30, 40 rows of data. So here's another example. Again, column that's pretty much worthless and a couple other criteria. And this one gets a little messy, but what we did here was we took the same approach. We applied the created an index where we applied the columns that are equal clauses, like for example, version status, and that was the only one. So then we had to resort to putting on our order by columns, the received on and the object ID, followed by our other criteria, document status. Document status, because let's see as I look around, object class ID we also did. Yeah, they have some column names that are kind of cumbersome. And then the document status. So again, we're doing the same thing. We applied our equals as the first column. There's only one in this case, then our order by columns, and then our additional filtering columns, which have either 2 or 5 values. And unfortunately, those additional filtering criteria are quite poor. But see, the other problem is with these queries, they have such low cardinality, you end up with so much data qualifying, you have to retrieve all that data, sort all that data. You're talking about a long-running execution. That's why we take this approach. This way, we're not retrieving all the data, sorting it, and returning it. We're just stepping through the index and pulling back the rows that we need in the proper sequence. So here is the explain output. And you can see what's interesting on it, though, it has a very high timer on count. Why? Because I think the optimizer really doesn't know what's going on here, but we've got the index we need. We're scanning through it properly. We're only going to look for the data we need, and it's much more efficient versus, again, grabbing all the data, sorting all the data, and returning what you need. Here's another example, and we have a couple that are very similar now. So again, cardinality on one of these guys, so I'm ignoring it, but we got, client name, that's pretty good. We got 30,000, but again, there's a table with millions and millions of rows. Object class ID, cardinality 12, not so great. Version status, cardinality 3. So what we did here, version status being a very small column, we put that out at the lead. And because they're looking at the ones that there's a low amount of data, it's definitely not equally distributed. Followed by object class ID, followed by our client name, and then our object ID. Now, what's interesting to note here is there is an order by on client name. Well, we have an equals on it, so obviously we don't need to have that. It's in the index and it suffices the equal as well as the order by. Descending doesn't matter because we have an equals on it. We're only going to have one client name. And then we have the object ID. Again, there could be paging on this same thing. It'll still work just fine. Again, just step right through the index up to the 400 as specified. And again, we made it clustered, etc. Like I mentioned, that descending really doesn't matter in this case because we have an equal clause on the client name anyhow. And then we got the before and after access paths. We'll zoom in a little bit just so you can see that a little better. You can see where, again, it was using the wrong index and sorting all the data that it was pulling back, pretty high cost. I'm sorry, it's only scanning the RID, sorting the RIDs. Then it pulls back the data that it needs using list prefetch, pulls back the data. Now it's got to sort it for the order by, ends up being high cost. Now, once you have the right index, you can see totally different situation. Physical sorting is gone. The sorting of the RIDs for list prefetch as well as the sorting to satisfy the order by, just totally gone. Much lower cost. And there's a comparison between the before and after. Here's another example, very similar, just a different column. This one is on policy number. And the reason I included this, very similar again, is that here the order by is different and there's a descending. Now, if you're using reverse scan indexes, it probably doesn't matter, but I believe that you're covered. But we, in this case, would add it as a descending sequence, collating sequence on the index. So we included that here. But very similar. And in fact, this one has slightly better cardinality. I think the other one was in the 30,000. This is in 64,000. Same type of comments here. Again, the only difference is talking about this descending sort sequence that I mentioned. And again, same type of results. You can see what was going on here, and then you can see what happened here afterward. You know, big difference in the and just to note the descending sequence, collating sequence on that column. Same kind of comparison. Now that's sorting, and the main thing to keep in mind is to use your indexes to eliminate those physical sorts. And a lot of times you're using them in conjunction with, you know, how many rows to fetch and optimize the query for that many rows, etc. And it just makes sense if you have searches that are potentially bringing back large amounts of data and you just want to be able to eliminate those physical sorts so that you're not going through the whole table and just doing tons and tons of I/O. And Martin, if you're still there, I think this is a good breaking point because we're probably about 2/3 the way done. If you want to interject something.
Yes, I am here. Let me take control back quickly. I'll
Sure.
Just make myself the presenter, and let me just do this and show my screen. There we go. And now I should show the uploaded advice video for today. Got a new logo from GoToWebinar. There we go.
some advice.
Let me go back to monitor 2 and make you the presenter again. Thanks for that. Just have to find the right Jim Bean again. Did I do it?
Yes, you did.
Perfect. Awesome. Take her away. Thanks so much.
Okay, hopefully you guys can see my screen now. We'll pick up on referential integrity. You know, there's a couple different types. We see a lot of application enforced besides the DBMS enforced, but lately a lot of apps are, just kind of deferring to DBMS handling it since they're much more efficient. There's a couple different types that I'm going to go over just real briefly because a lot of folks are already familiar with this. You know, just a one column, declaring a column unique, whether it's one column or multiple. I have some simple examples here using the claim ID from a claim table, claim line from the, claim ID plus line item from the claim line table, and setting up relationships there. And that's just to prepare us for what we want to talk about next. So first off, if you want to have a unique index, obviously one or multi columns, just define it as unique. And this does a couple of things. It tells the optimizer that it's unique. The optimizer will favor using that index. Why? Because it knows that it's unique. It knows that the chain length is always 1. And knowing that helps because the optimizer will know that this column or even this group of columns is unique. And we'll talk about including columns coming up shortly for index-only access. That's relatively new. I forget exactly when that came out. It's been out for quite some time, though. I'm sure everyone has heard of and used that. Some more on RI with foreign key relationships between the parents and the children. A claim row, for example, a claim row can't be inserted until he's got a parent on the claim table already. So the claim line row can't be inserted. The database will check for the existence of that claim ID that's being inserted on the claim line table up on the claim table. So obviously you want to have an index on that claim ID already on the claim table. And in most cases, I'm sure it's already there because that's probably the primary key up on the claim table. Real simple things. It can get more complicated, especially when you refer to some other tables where maybe the relationships aren't so clear, and we'll see an example of that. Now keep in mind some of the options on your RI relationships. When you are looking to delete all the children at the same time when you delete a parent. So let's say you wanted to delete a claim and you want to delete all those claim ID rows at the same time without having to delete them each individually. That's when you use the cascade. And it's just like it sounds. It's going to cascade those deletes down and get rid of all the children, grandchildren, great, etc. It'll go through the whole structure and get rid of all of them, assuming that all the relationships specify cascade. But that we see that used or deployed, but not often. What's more, more important or happens more frequently are people tend to use the restrict option so that the children rows aren't deleted. I think there's a feeling that they'd rather do them themselves so that they know that what they're deleting exactly and then go up and delete the parents. And that's perfectly acceptable too. I mean, in reality, that's kind of what DB2 is doing behind the scenes. But I did want to just mention the use of the cascade option because it is there, it is available, and it can make the processing a little bit simpler, a little bit clearer if you just delete the claim row. Let's see, the other option, there's a third option, and it's called the set null option. I don't know that I've ever seen this deployed. I mean, I've seen examples, but I've never seen it at our company. You can, instead of cascading the deletes or restricting the deletes, you can set them to null. So the children would become null. And then what do you do with them? You see, that's the thing. So like I said, that's not a very popular criteria. You have the same options on update statements because maybe you're updating the rows and you want to propagate those updates to the children. Like for example, you're going to change the claim ID and you're going to change that on the claim ID table, then the claim line table, maybe you have some comment tables, etc. So that will propagate the same way using updates if you use Cascade. Again, if you use restrict, it won't propagate. So now here's an example. And if I remember right, this is the one, yeah, I obviously pulled this from the conference. And it looks pretty simple. We're just altering the claim line table where we have this foreign key constraint on the claim ID column. It's referencing the claim table, which means that claim already has to be out there using the claim ID. Like we mentioned, it probably is. And on delete, we're going to cascade. On update, we're going to restrict. And the index on the claim line table on claim ID line item, that'll suffice since we already have the claim ID. You know, that's the leading column. So here's a very straightforward delete, or what looks like one. We're just deleting from a table called reason not covered, where the RNC is a particular value. And it doesn't matter what that value is. They just didn't use parameter markers here. So real simple delete. We're going to delete some row probably from this table, or maybe several rows. But here's the explainer, the access path. Let's zoom in and see what's going on here. Now here's our delete from the reason not covered table using the RNC index. Great, it's indexed. It's a small table, but it's indexed. Okay, fine. But what are all these other 5? And some of them have humongous costs in the millions. And this one isn't bad. Well, that one's only 273 rows. But look at all these other guys. And why are we doing table scans? So what happened? Why did we add in those 5 table scans? Well, because we're talking about RI, I'm sure you already know the answer. Now, if we look at the DDL, we'll see that there are foreign key relationships back to those other tables. So what DB2 has to do before it executes this delete, he's got to go and make sure these things are taken care of. So it's checking. And because there's not the proper indexing, it has to resort to table scan. So obviously we put the proper indexing in place. So what looked like a real simple delete statement from one table actually, you know, caused some issues, performance issues, because it had to go out there and scan other tables, 4 of which were quite large. Let's see. Now we're going to talk a little bit about index-only access. We've actually mentioned it a couple times, going back to the first slide or 2 of today, talking about why not to use select asterisk, because you're going to eliminate almost all potential to use index-only access. So what we do is we do know that there are certain queries that maybe only take a column or 2 more than the actual index columns. So if it's a unique index, you can just do an include on there. You still retain the qualities of a unique index, and the optimizer knows that, and the DBMS knows that too. It's still a unique index, but you're putting on these other columns. You're going to include those other columns on the index using the keyword include so that it's index-only access. And it's true, this is going to increase the size of the index. It's going to increase the time to create and maintain it, but it benefits other calls. And the goal is to eliminate physical I/O. Now you can also do this with non-unique indexes just by adding columns to the index, not using the include option. The include option, again, is to kind of guarantee your uniqueness on the other columns. So that's where include comes in. But again, even on a non-unique index, you can add columns to give yourself some index-only access. Again, it avoids the physical I/O to the underlying table data pages. But I would caution you, don't overuse the feature. In a lot of cases, it makes sense. Okay, I'm going to pull back, 1 or 2 columns. Maybe it's a date, maybe it's a status or something, and it makes sense to use it. But in other cases, I've actually seen where like the, I think it's called something different now, but they used to call it the index analyzers. They would make recommendations, and their indexes have every column that's being selected, and it turns out to be it's 40% of the columns on the table or some ungodly length, and you can end up with indexes that are 20 plus columns. That's not where it's going to help. You're not trying to eliminate all access to table data pages, what you're trying to do is eliminate it where it makes sense, because sometimes you may have a really simple query and you just have to add 1 or 2 short columns as include columns or as additional columns on a non-unique index, and it makes all the difference in the world. But it's not meant to resolve your, every single query. Now, in the old days, before you had the include option, if you had a unique index out there, and which you obviously it's defined unique for a reason, you want to keep it that way. In the old days, you used to have to create a second index with the same columns and whatever additional columns, so you ended up with redundant indexes. Well, that gets back to the include option, and there's an example down there below where maybe you're going in by claim ID and you have a lot of queries or searches that go in looking for just the claim status, which would be probably a 1 byte field or something relatively small. In that case, it makes sense to just include that so that only the index is accessed, not the table data pages. And again, the important point is by using the include option, claim ID itself, that 1 column alone, remains unique. If you did not use the include option, you created a 2 column index called claim ID, claim status. That's different. That now means the combination of those 2 columns are unique. That's not what you want here. So again, by having this include option, it provided DBAs the ability to have an additional column or 2 or a few on a unique index without affecting the unique constraint. That's the original intention of the index. That way we get rid of those redundant indexes. Now, one fetch access, it's a very special case of the index-only access. And there's an example here. We see this quite a bit where you're looking for, usually it's a maximum date of some date field from some table with some other criteria. Sometimes it's the minimum date, but it's almost always maximum. And we're looking for, okay, when did something take effect? When did something expire, etc. And obviously this index would benefit, the SQL call would benefit from a index on the account num and the subscriber pin, but then it would have to go to the data pages to get effective date. Well, okay, we can just put that out there. But what's important here is we would create that with a collating sequence of descending on effective date. And the reason for that is we want to make that index only access, as I mentioned, and 1 fetch. So when it first hits that index, it's got the account num, the subscriber PID, and then the first effective date it picks up is the maximum because the collating sequence is descending. So that's why we do that. Again, it's just trying to make the query as optimal as possible. Now this happens a lot when you've got sub-selects that you're passing back to a main select. We see this quite often in some of our queries, so it can help quite a bit. So not only are you looking at optimizing the main select, but the sub-select where you may see something like this. Now there's an example here from a 2001 change, and this was before there were reverse scan indexes and things, and this actually came from a mainframe DB2 environment. And the reason I like to include this every now and then is because this is decades old. I forget exactly. I know it's like 20 years old, or yeah, 2001. And something really simple. And this was back when they were pulling some random number from some table, and I think they were just adding 1 to it later and updating it. But anyhow, they were doing this stuff, and all we had them do, they already had an existing index on the A random num column, but the collating sequence was ascending. So this thing would run and run and run and run. And there was a lot of contention because then they would try to update it. And there were abends daily on this happening, and all we did was we made it descending. Why did we make it descending? Again, because of the select max. It can make a huge difference. This one change alone back in 2001 saved over $1.5 million per year in CPU charges because I forget how many engines we freed back then. But plus, more importantly, were all the intangible savings because there were abends, customer wait time, frustration, rework, etc. People were quite upset, and it was such a simple change just to make it a descending collating sequence. And then you can see the difference. This was implemented again on 9/16/2001. This I had mentioned earlier on where I had mentioned indexing and some new features. And again, I'm going to say relatively new features because these really aren't all that new. But like expression-based indexes, the reason why I added this in was because I wanted to make sure that people realize that these capabilities are there, and looking at the mixed impact of mixed case data, because we see that quite often as well, where data is entered in free form, could be lower or upper, and then it's used in searches, and sometimes the data isn't coming back right. Well, got to look at it, and seen a lot of OR conditions where people are looking for the upper or the lower version. Well, what if it's mixed within? So there's a lot of things to consider here, and especially when you're searching. But one of the things that we did try to do was we looked at a couple options. I mean, ideally, if possible, convert to either all uppercase or all lowercase before the data row is inserted. Why? It's a one-time thing, and once it's out there correctly, it's out there. The bad thing about that is that means you're stuck to either that lowercase or uppercase, and that's not really correct for things like some last names that I know of, in fact, some colleagues. So if mixed case is required, in other words, you can't just convert it before insert, well, then this is what you do. You insert it in mixed case. Why? Because you want to make sure it's displayed properly. So when it's selected, you'll get the mixed case back. But settle on either all upper or all lower when you're doing your searches, and then create an index that's appropriate for that. Again, this isn't going to affect how the index is displayed. It's only going to affect how it's searched. And in our case, this particular one using last name, we used upper, but in some cases like email address and other things, we use lower. This way you get the proper match, and you bring back the proper data, and you're going to display the original column, which was entered either upper, lower, or some mixed case version. So here's an example where this particular one is using lower of email, because that was the more frequent one. And we also were doing that with the SSO ID. I don't have the actual index here, I don't think, but just these two. So what we did was the application, when they were doing their searches, they were displaying the mixed case field, but they were always inquiring on the lowercase version. And we created indexes on the lower version, as you see there at the bottom of the slide. And there's the change. For whatever reason, these queries started occurring much more frequently toward the end of June, and that's how it became a problem on our radar. And by the end of August, we had implemented those two indexes on lower SSO ID and lower email. And you just see the improvement that we realized. Exclude null keys. This is another one, relatively new feature. Again, DB2 version 10.5. And I had never used it before. This is just a few months ago. And what we had was we had a FileNet database with a column that should always be unique, well, almost always unique. That same column, that same table would also house template rows. And in that case, the template rows had null for this particular column. And we'll see this example. So we wanted to enforce a uniqueness. And again, we're trying to stay away from all those redundant indexes. So what we did was we applied the exclude null keys. And what that does is it allows you to have multiple rows that will be null, but any values of that column or columns in the index that are non-null, they have to be unique. So you can have 100 million rows that are all unique with values, and then you can have 10 rows for templates, and they're all null. So looking at the DDL for the index, you see that on the DCN, I think that stands for document control number. So document control numbers are unique. At least on this particular implementation, they are unique. So we have millions, tens of millions of rows with unique document control numbers, that's fine. Oh, but we also have some template rows and they were null. So at first, there was concerns that, well, we can't make that unique. We need to make that unique. Well, I had heard of this in an earlier conference, whatever, looked it up on the internet. Sure enough, hey, we want to use this relatively new feature called exclude null keys. So it's the first time we've ever had to use this option. Found out too, it helps a lot with the compatibility for migrations from Oracle, because apparently it's a default there. And so we had to use it here. To my knowledge, it's still the only time I've ever recommended it, but it definitely resolved our situation. And we did not have to do anything else other than what you see right there, so that now the DCN is still unique when it's populated, and we can have multiple rows that are null, not just a single row, but multiple rows that are null. And of course, that's okay, because remember, a null indicates no value is known. It doesn't mean the value is null, it means no value is known. So therefore you can have multiple rows of null, and that's still okay. Flash storage, this will be quick. We all know there's different kinds of storage out there. So now this really should have been in the hardware section, probably back on the first part one. But you know, there's a couple other things that we did with a project back several years ago. We did some major data purging, some database configuration changes, including a lot with HADR, created indexes, changed indexes. We did a bunch of upgrades everywhere. We actually reduced our CPU, which is good. And we applied SSD or flash storage for all of our tables, indexes, and transaction logs, a whole bunch of things all at once that we did several years ago. And we measured the overall impact. And what was interesting, though, was we found, inadvertently found a great way to measure, well, what happens when you're not on SSD? Well, what happened on June 30th is we were inadvertently migrated off of SSD. And then 2 weeks later, we were put back on. But it's interesting because if we take a look at this, well, before I go into details, you can see this is on a daily basis. We're seeing 5, 6, 7, sometimes 7.5 days worth of time. How can that be? It's a single day. It's a multi-processor environment. So, of course, you know, there's multiple things happening. And you can see what we're doing. Then you can see where we made our changes. And again, this isn't because we added CPU. We actually dropped CPU 25%. This was fixing I/O problems. This was going to flash. This was additional indexing, some purging, you name it, a whole bunch of things. But what I really want to point out is this part right here. What happened here on June 30th, I think it is, to about July 13th. That's when we were migrated off of SSD in error. So you can see that our times per day went from these, this is in days, from about maybe 8-10 hours per day, we jumped up to somewhere around 30 hours per day. And that was because we were migrated off of SSD for that time period. It took us 2 weeks to get back on because we could only do it on a weekend to get migrated back on. But it's just interesting. So we were able to see, okay, out of this big impact here, we know what happens when we're not on SSD. So that was just an interesting find. Makes a difference, and it's good to know that each of those different sets of performance improvements that we talked about back here, they all had an impact. You see the big impact here, and then we know this one here is due to the SSD migration. Implementation details, again, that same project, I just wanted to mention one other thing. We maintained replication and bidirectional failback. Why, how, etc. Okay, let's just briefly go over that. We had to upgrade the DBMS because we were out of support. That required an OS upgrade. That OS upgrade then required a hardware upgrade. Well, right there, think about it. So now we're going to have old hardware, new hardware. We have 2 sets of hardware. That gives us capabilities that you don't always have when you're doing an upgrade. So we were able to give them bidirectional failback capability because we had 2 sets of hardware. So while we were still, let's talk production, while we're still operating on the old platform, we moved data to the new platform. We purged it, we reorged it, we run stat it. And then we were replicating. During all of this, we were replicating all the updates from the operational database that was still running on the old platform. Then after, I think it was 2 weeks, yes, we migrated, which really means we repointed the app to the new platform, the new set of hardware. And what was good about this approach too was while we were at the beginning of that new hardware phase, let's call it the first few days, I think it was 3 days after we migrated, the first 3 days, while we were doing that, we were still replicating all the database updates, inserts, deletes, etc., back to the old environment. Well, why did we do that? There's overhead. Yeah, there is. But that gave us failback capability to the old environment if we needed to. We could have just repointed back there. Fortunately, we never had to. But after several days, we cut that lifeline to reduce that overhead, which wasn't so bad. But and then we freed up the old platform. So we use dprop, what we used to call dprop or SQL replication these days, for the data propagation in both directions. And I just wanted to mention that because if you're ever got the hardware available due to something like this, or because you just have hardware available at your disposal, this is really nice because for such a large application, we were able to do it just by repointing to the proper VIPs and the new VIPs. And by doing this, it really minimized or shrunk the outage cycle to something very, I don't know, usable by our user base. Because what if we told them, yeah, we want to bring down the system for days so that we can do all this work? No, you just can't. I mean, we were doing massive purging and reorging, et cetera. We did all that behind the scenes and then swapped over just by repointing to the new platform. So it's just a different approach, but it worked out very well if you have hardware available at your disposal. And I know you don't always do, but if you do, something to consider. And that's all that I had for today, unless there's any questions. I think there's just some references here to those other presentations that I mentioned earlier that have been made at both the Central Canada DB2 user group and the International DB2 user group over the last several years.
Well, that's a great job.
Oh, thank you. Did we have any questions?
Surprisingly not, but I think you were very clear on what you're doing. I found the comments on SSD kind of insightful, where sometimes performance changes get inadvertently backed out, and you see, well, we did the right thing because things got bad. And
yeah, you know what's interesting about that one too is when we were in the project, they were looking for justification. Well, what kind of performance improvements will we see? And it was difficult to provide that information, but we found out a year or so later when they were migrated off, and now we've got that information going forward.
yes,
and how important being on SSD was for this application.
Sometimes you learn more lessons by having things go awry than you do by doing
Yes.
everything perfectly.
That's for sure.
One of my other favorite comments was from another good friend who told me that when they first brought in SSD, they had a consultant project manager who explained that SSD was really good because it spun at 50,000 RPM, which is a good joke for a solid state device that doesn't spin at all. But I hope after having provided such wonderful and erroneous information, I do hope that at some point he did learn what was going on. I'm optimistic,
Let's hope so.
All right, I'm going to take back control for a minute here to ask our world famous last question that we ask on all of these shows, which is, did you learn anything today? And I'm launching that question just now, so people can see that. Hopefully, I can see it somewhere. Interesting. And the answer is exactly what we like to see, which is 100% of our good-looking studio audience learned something today, which is fantastic. A large percentage of the audience voted, so that's even more affirmation for you. That's just great. So I'll just put up our closing slide here. Which is basically thanking DBI again for the use of the room, so to speak. And with that, I will cue the music. Thank you profusely as many times as I possibly can as the music plays, and as we end the broadcast, and we invite people back for our show next week with Mike Cotignolo of BMC on the System Z side. So y'all have a great weekend. Remember, if you're in North America, this is likely the weekend where you're going to set your clocks forward for daylight saving time, or summertime if you're in Europe. It might be a different date in Europe. I know they do things differently over there, but there we go. So here comes the music. Here comes the profuse thanks again. Everybody have a great time, great weekend, and we'll see you next time on the DB2Night show. Bye-bye. Thanks again, Jim.
Sure. Thank you, Martin.
All right. Bye-bye.